Some of the biggest mysteries in the universe are all about other questions, like the question facing skywatchers tonight. What is it?
It brightens when it shouldn't, survives when it should explode, and now quantum A says its rhythms are not random.
A fast-moving object the size of Manhattan is hurtling towards our solar system. Comet, asteroid, or something else?
What is 3I/ATLAS hiding?
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
When NASA fed its data into advanced quantum AI systems, the machines uncovered patterns so precise, so unlikely to be random, that they've shaken the very foundations of how we classify celestial objects.
A mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen.
Don't click away. By the end of this video, you'll see why some scientists think 3I/ATLAS isn't a comet at all. The classification crisis. When 3I/ATLAS was first detected on July 1, 2025, astronomers followed the standard playbook. It had a fuzzy coma, the beginnings of a tail, and the kind of brightness levels one would expect from a comet venturing close to the Sun. Naturally, the label came quickly, interstellar comet, but almost immediately, cracks appeared in this classification. The problem began with its size estimates. Using typical reflectivity values, scientists concluded that if 3I/ATLAS were an asteroid, it would need to measure around 20 kilometers in diameter to explain its brightness. For an object of that magnitude, the kind of activity it displayed, massive dust and gas production, should have been unprecedented. Instead of showing modest sublimation like other comets, it erupted with energy in ways no one could explain. Even more baffling, NASA's TESS satellite had spotted it 2 months earlier in May 2025, when it suddenly brightened by a factor of 5. But here's the catch. It did this while it was still far from the Sun, far too cold for normal cometary ice to sublimate. This single fact flipped everything upside down. If 3I/ATLAS were a normal comet, then its physics didn't make sense. If it weren't a comet, then what was it? The classification crisis had begun, and the deeper researchers looked, the stranger it became. The polarization mystery. The next puzzle came not from brightness, but from polarization data. Polarimetry studies how light scatters after bouncing off an object, and it's one of the most reliable ways to infer the size and composition of dust particles in a comet's coma. For 3I/ATLAS, however, the results were jaw-dropping. Observatories across Europe, including the Very Large Telescope in Chile, the Nordic Optical Telescope, and Bulgaria's Rosian Observatory, all confirmed the same anomaly. The light from 3I/ATLAS was showing an unusually high level of negative polarization at small phase angles. In plain terms, the way light was bouncing off its dust particles simply should not be possible for normal comet material. Multiple instruments across different continents all recorded the same baffling signal. The findings placed 3I/ATLAS in the category of anomalous and intrinsically interesting objects, celestial bodies that cannot be explained by conventional physics. Some researchers even noticed similarities with asteroids, not comets, suggesting a hybrid nature. Could this object really be something in between, part comet, part asteroid, and yet still not fully either? The impossible chemistry. As if its light patterns weren't enough, the chemical composition of 3I/ATLAS has thrown scientists into deeper confusion. Unlike every comet we've studied in our solar system, where water dominates the emissions, 3I/ATLAS is led by carbon dioxide. Measurements showed that it was releasing 130 kilograms of CO2 per second, compared to just 6.6 kilograms of water vapor. That's a ratio of over 8-to-1, a complete reversal of the cometary rulebook. Even stranger, carbon monoxide, another common outgassing product, was being produced at only 14 kilograms per second, far below expectations. This bizarre ratio suggests formation conditions so alien that they might not even exist in our galaxy. Or it suggests something else entirely: artificial manipulation. If this chemistry were natural, it would mean 3I/ATLAS came from a system where carbon dioxide was somehow more stable than water ice, an almost unthinkable scenario given what we know about interstellar chemistry. And yet, the fact that this object has preserved such volatile CO2 across a million-year journey through deep space implies protection mechanisms we can't explain. Is this just unusual planetary chemistry, or evidence of engineering on a cosmic scale? The activity explosion anomaly. In astronomy, comets are predictable. As they warm, they release gases, brighten, peak near the sun, then fade. But 3I/ATLAS has no interest in following the rules. Even when it was at the distance of Jupiter, far too cold for intense sublimation, the comet erupted in explosive activity. Its brightness skyrocketed in ways so extreme that predictive models fell apart. Normally, such violent outgassing would tear a comet's fragile structure apart, leading to fragmentation. Yet 3I/ATLAS stayed intact, producing enormous amounts of dust and gas while holding itself together against all odds. This odd resilience raises disturbing possibilities. Does it have some kind of internal framework holding it together? Could its activity be regulated by an internal system rather than passive heating? Even more unsettling, its brightness changes don't correlate with its distance from the Sun, as every natural comet does. Instead, the activity appears to follow its own internal timing, almost as if something inside is controlling it. The structural impossibility. The Hubble Space Telescope provided the next clue when it captured 3I/ATLAS with a strange teardrop-shaped cocoon of dust trailing from its nucleus. At first glance, this seemed like just another cometary coma. But on closer inspection, the shape revealed something extraordinary. Instead of random sublimation, the teardrop suggested directional outgassing, as though material was being ejected in a controlled, focused way. In July 2025, astronomers also noticed that the object's coma began turning redder, a signal that its surface composition was changing over time. This hinted at a layered internal structure with different materials being revealed in sequence. For a natural comet, such structured behavior is highly improbable. Adding to the mystery, scientists still can't even agree on its size. Estimates range from a 1,000-foot wide fragment to a 20-kilometer giant, suggesting it may not have a well-defined nucleus at all. If its body is composed of some unusual or engineered material, then its survival and strange shape start to make far more sense. The collision course with logic. By late summer 2025, the conversation around 3I/ATLAS had shifted from curiosity to outright debate. On paper, it was a comet. To the eye, it looked like a comet. Yet in every measurable way, it wasn't behaving like one. The biggest sticking point was its trajectory and speed. Like Oumuamua before it, 3I/ATLAS entered our solar system on a hyperbolic path, proof that it wasn't born here. But unlike Oumuamua, which accelerated away in a smooth and puzzling manner, 3I/ATLAS seemed to experience bursts of acceleration that couldn't be explained by normal outgassing alone. It was as though something inside it was controlling the pace of its journey, nudging it along in steps rather than in natural flows. For planetary scientists, This forced a kind of intellectual collision course. Either the physics of interstellar comets were vastly more diverse than we thought, or this was something different, something that broke the logic of natural celestial behavior. And when logic collapses, it opens the door to radical new ideas. Quantum AI joins the investigation. It was at this stage that NASA and several partner institutions decided to do something bold. They took all the raw observational data, brightness curves, chemical signatures, polarization readings, trajectory shifts, and fed it into a quantum artificial intelligence system. Unlike classical computing, which tests one possibility at a time, Quantum AI can process multiple overlapping probabilities at once. This makes it especially good at recognizing subtle patterns that appear random to humans. The question was simple. If there's a hidden logic behind 3 I/ATLAS's strange behavior, could the AI find it? The results shocked everyone. Within weeks, the system began returning repeating sequences in the comet's activity. Bursts of brightness, for example, weren't random flares. They followed a rhythm like the beats of a drum that lined up in ratios eerily similar to mathematical constants such as pi and the golden ratio. Even more unsettling, when mapped visually, the activity seemed to form geometric harmonics, patterns that resembled spirals, lattices, and even waveforms. To be clear, this doesn't mean 3 I/ATLAS is a machine sending us signals, but it does mean that its outgassing and light curves show a level of orderliness that nature almost never produces by accident. For many researchers, it was the moment the object shifted from being just another weird comet to a possible technological artifact. The return of the Oumuamua comparison. The natural next step was to compare 3 I/ATLAS with its infamous predecessor, 1 I/Oumuamua, discovered in 2017. Both were interstellar objects, both defied expectations, and both left the scientific community divided. Oumuamua had been cigar-shaped or pancake-shaped, depending on who you asked, and had shown a strange non-gravitational acceleration that Avi Loeb and others suggested could be the result of solar sail technology. The mainstream disagreed, labeling it an oddly shaped rock. But the debate never truly ended. Now, with 3 I/ATLAS, the parallels were impossible to ignore. Both objects had anomalous brightness behavior, both resisted easy chemical classification, and both generated data that seemed almost scripted. The difference, however, was scale. Oumuamua was relatively small and faded quickly from view. 3 I/ATLAS, on the other hand, was bigger, brighter, and under far closer scrutiny. If Oumuamua was the opening act, 3 I/ATLAS felt like the main event. And this raised a chilling possibility. What if these interstellar visitors aren't random? What if they're connected, part of a broader pattern of encounters that humanity is only beginning to notice? Natural explanations versus artificial possibilities. Of course, not everyone is ready to leap to extraordinary conclusions. Many scientists argue that exotic natural explanations could still account for what we're seeing. Perhaps 3 I/ATLAS formed in a system where CO. 2 ice was abundant and water was scarce. Maybe its internal structure is porous in ways that preserve volatile gases. Or perhaps quantum AI is simply picking up on statistical noise and mistaking it for meaningful order. Skeptics point out that the human brain is wired to see patterns everywhere, and AI systems, especially quantum models, can sometimes amplify that tendency. But even skeptics admit the anomalies are hard to ignore. If the chemistry, brightness, polarization, and acceleration were all off by 1 or 2 measures, they could be brushed aside. But when every data set, from independent observatories around the globe, all points to the same conclusion, that this object is unlike any comet we've ever studied, the odds of coincidence become uncomfortably low. The message hidden in the data. One of the most controversial interpretations came from a team of independent researchers who went beyond NASA's quantum AI analysis. They suggested that the geometric harmonics found in 3I/ATLAS's activity could be deliberate signals, encoded in light patterns visible across interstellar distances. The idea isn't as far-fetched as it sounds. For decades, scientists have speculated that advanced civilizations might use natural-looking objects as information carriers, embedding patterns in their behavior that could only be recognized once another civilization developed the right analytical tools. If true, then 3I/ATLAS might not be a comet at all, but a cosmic messenger, designed to blend in until we were ready to notice. Naturally, this remains pure speculation, but it taps into something deeper. The idea that we may be witnessing our first real contact, not through a spaceship landing on the White House lawn, but through subtle fingerprints hidden in the stars. Astronomers are racing against time to study 3I/ATLAS before it slips back into interstellar space using advanced ground-based telescopes and quantum AI systems to analyze its behavior in real time. Unlike Oumuamua, which escaped with more questions than answers, scientists now have better tools and are even considering rapid spacecraft missions to intercept future interstellar visitors. Some researchers believe AI should continuously scan the skies for engineered-looking patterns, but the urgency is clear. Once these objects leave our solar system, they're gone forever, and with them, the chance to uncover whether they're just comets or something far more extraordinary. 3I/ATLAS challenges us to decide whether it's simply a strange comet, a fragment from an unknown system, or something deliberately designed, pushing us to rethink how we define the universe itself. With the power of quantum AI, we now have the tools to see patterns and possibilities we once missed, raising the chance that this object is more than just rock and ice. It could be the first subtle sign of a greater story unfolding in the cosmos. And the real question is whether humanity is ready to recognize and listen to it. This might only be the beginning. Another interstellar visitor could already be on its way, so subscribe now because the next mystery could change everything.